This tiny device can produce electricity using nothing but two pieces of metal and a handful of ordinary soil. No fuel tank, no power outlet, no complicated machinery, just dirt, water, and a simple chemical reaction that was understood more than a century ago. Yet despite being demonstrated for generations, this strange little invention almost disappeared from public memory. Here's the surprising truth. One of the oldest ways humans created electricity is also one of the simplest. Today, though, powering even the smallest devices has become a billion-dollar industry. The average person now depends on dozens of rechargeable batteries every single day inside phones, watches, wireless earbuds, cameras, laptops, and countless smart devices. Every few years, those batteries need to be replaced. Modern battery technology has become incredibly advanced, but it comes with a hidden cost: complex manufacturing, rare materials, mining operations, factories consuming enormous amounts of energy, and a growing mountain of discarded batteries that are difficult and expensive to recycle. The solution we are usually offered is always the same: buy a newer battery, a larger power bank, another charging system. What if electricity didn't always have to begin inside a factory? What if, in some situations, the ground beneath your feet could become part of the power source? Now, this doesn't mean dirt is secretly producing unlimited free electricity. The science is more fascinating than that. Soil isn't the fuel. It's the environment that allows a chemical reaction between metals to happen. That reaction was powerful enough to capture the attention of some of the earliest electrical pioneers in history. The real question isn't whether this idea works that was proven long ago. The real question is, why did a technology that could create electricity with materials available almost anywhere become almost forgotten? To answer that, we have to travel back to a time when electricity was still a mystery, a time when scientists weren't carrying smartphones or working in advanced laboratories. They were experimenting with glass jars, metal plates, wires, and even the Earth itself. In the early days of electrical discovery, researchers realized something unusual. The planet beneath us was not just a passive piece of ground. It could help complete an electrical circuit. When two different metals were placed into moist soil and connected together, something invisible began to happen. Electrons started moving. A small current appeared. It was weak compared to modern batteries, but the idea was revolutionary. The Earth itself could become part of an electrical system. One of the earliest examples came from experiments inspired by the discoveries of pioneers like Alessandro Volta, whose work in the late 1700s proved that electricity could be created through chemical reactions. Volta's invention changed the world because, for the first time, humans had a controlled source of continuous electric current. Hidden inside that breakthrough, though, was another idea. If chemical reactions between metals could create electricity, could the same principle work using the natural environment around us? Over the following decades, inventors and experimenters explored unusual ways of generating power. Some placed electrodes into water, others experimented with minerals, plants, and the ground itself. The concept became known as the Earth battery, a technology that looked almost too simple. Two metals, some moisture, a connection, and a tiny flow of electricity. For a world just beginning to understand electrical power, it was a remarkable discovery. Then something happened. Electricity became commercial. Power stations appeared. Large companies began building centralized systems, and simple inventions that produced small amounts of energy started to disappear into history. Not because they failed, because the world moved toward technologies that could produce more power, more quickly, and more profitably. The Earth battery was pushed aside, a forgotten idea buried beneath decades of technological progress. Today, though, as people search for cheaper, simpler, and more sustainable ways to generate energy, this old experiment is attracting new attention. Sometimes the future is not a brand new invention. Sometimes it is an old idea, waiting for a new generation to understand what it was capable of all along. At first glance, an Earth battery looks almost too simple to be real. A few pieces of metal pushed into the ground, a wire connecting them, and somehow, electricity appears. The real story is happening at a microscopic level. Inside that ordinary patch of soil, millions of tiny chemical reactions are taking place. Picture two people standing on opposite sides of a river. One has a bucket full of water, the other has an empty bucket. The water naturally wants to move from the full side to the empty side. Electricity works in a similar way. Electrons want to move from one material to another. The Earth battery simply creates the conditions that allow that movement to happen. A typical Earth battery uses two different metals. One gives up electrons more easily, such as zinc. The other accepts electrons more easily, such as copper. When these two metals are placed into moist soil, the water and minerals in the ground act like a bridge between them, a bridge called an electrolyte. Zinc begins to release electrons through a chemical process called oxidation. Those electrons travel through the external wire toward the copper electrode. That movement of electrons is what we call electric current. The soil itself isn't creating energy. It's allowing the chemical reaction between the metals to continue the same basic principle behind many modern batteries. A battery is essentially a controlled chemical reaction that separates charges and gives electrons a path to move. A commercial battery carefully controls this reaction inside a manufactured container. An Earth battery uses the natural environment as part of that system. The advantage: it can be built almost anywhere. The disadvantage: the amount of power is extremely limited. A small Earth battery might produce around half a volt to a little over 1 volt, depending on the materials, moisture, soil conditions, and electrode size. To power anything demanding, you need many cells connected together. For small sensors, emergency experiments, and educational projects, though, the idea is surprisingly useful, and the history behind it is far older than many people realize. The story begins during the electrical revolution of the 18th and 19th centuries. 1800, Alessandro Volta creates the voltaic pile, the world's first practical battery. For the first time, scientists have a continuous source of electricity instead of short bursts from static electricity experiments. This discovery opens the door for thousands of electrical experiments. Early 1800s, scientists begin exploring natural electrical sources. Researchers investigate whether electricity could be generated through natural materials like soil, water, and minerals. The idea that the Earth itself could participate in a circuit begins to attract attention. 1840s Scottish inventor Alexander Bain, best known for improvements to early communication technology, explores electrical systems involving Earth connections. His work contributes to the broader understanding that the ground could serve as part of an electrical pathway. Late 1800s, Earth return electrical systems become practical. Telegraph engineers discover that the ground can be used as part of a circuit, instead of requiring two separate wires between locations. Some systems use the Earth itself as a return path, a major engineering breakthrough. The planet was no longer just where the equipment was placed. It became part of the machine. Early 1900s simple battery experiments become overshadowed. As electrical grids expand and commercial batteries improve, small-scale Earth-based systems lose attention. The world wants more power, more reliability, more control. Tiny sources of electricity become less attractive. One of the most fascinating moments in this history, though, comes from the forgotten experimenters who kept exploring unconventional energy sources. These weren't people trying to build giant power plants. They were asking a different question. What if electricity could be created from the environment around us? Working with limited tools but unlimited curiosity, many of their ideas were ignored because they didn't fit the industrial direction of the time. Large generators, coal plants, and eventually fossil fuel-powered systems dominated the future of electricity. Small natural systems simply couldn't compete. Today, the same limitation that made Earth batteries unpopular in the past has become part of their appeal. They aren't designed to replace a power station. They're designed for situations where simplicity matters more than massive output, remote sensors, educational experiments, emergency low-power devices, off-grid projects. The Earth battery represents a different philosophy of technology. Not bigger, not faster, not more complicated. Just a reminder that sometimes the most interesting inventions are the ones hiding in plain sight. A technology doesn't always disappear because it was useless. Sometimes it disappears because the world was looking for something else. For most people, the idea of pulling electricity from the ground sounds like a science experiment, something interesting, something you might try once. Throughout history, though, there were moments when creating even a small amount of electricity from the Earth became surprisingly valuable. Because sometimes the smallest power sources matter most when everything else fails. During the early days of telegraph communication, engineers discovered something unexpected. Long-distance communication systems did not always need a complete loop of metal wires. In certain conditions, the ground itself could help carry the electrical signal back to its source. When traditional wiring became expensive or difficult to install across huge distances, using the Earth as part of the circuit became a practical engineering solution. The planet beneath the cables was quietly doing part of the work. A reminder that electricity was not only something humans created, it was something humans learned to guide. Decades later, the same principle became useful in remote environments where running power cables was impossible. Weather stations, scientific equipment, and experimental sensors often face the same problem. How do you power a device when there's no electrical outlet nearby? Sometimes the answer wasn't a massive generator. Sometimes it was finding energy from the environment itself. Here's where the story takes an interesting turn. If this technology has existed for so long, why don't we see Earth batteries everywhere today? The answer comes down to one simple word: scale. Modern electricity is built around enormous demand. A single smartphone battery stores thousands of times more energy than a small Earth battery can provide. A modern electric vehicle battery contains enough power to move thousands of pounds of metal for hundreds of miles. A small soil-based cell cannot compete with that, and that's exactly why the comparison becomes fascinating. The modern battery industry is one of the most advanced manufacturing systems on Earth. Companies invest billions into improving battery chemistry, increasing energy density, reducing charging times, and making batteries last longer. It depends on highly engineered materials, controlled environments, and global supply chains. An Earth battery represents the opposite approach: cheap, accessible, but limited. Think of a modern lithium battery as a powerful engine built in a factory. An Earth battery is more like a small water wheel in a stream. The wheel will never replace a power plant. But if you need a tiny amount of energy in the right place, it can still be useful. Here's the most surprising part. You can build a basic Earth battery for less than the cost of a restaurant meal. What a simple version requires: a zinc-coated metal piece, such as a galvanized nail or zinc strip, around $2, a copper electrode, such as a copper pipe piece or copper sheet, around $3, connecting wires around $1, a small LED or low-power measuring device, around $2. Total cost, around $8 or less. The setup is straightforward. Place the zinc and copper electrodes into moist soil, keeping them separated so they don't touch. Connect the wires to each metal, then measure the voltage with a multimeter. If conditions are right, you'll see a small electrical reading. The ground has become part of your battery. Before anyone runs outside expecting to power their entire home with dirt, though, a few realities matter. First, power output. An Earth battery produces a very small amount of electricity. It can demonstrate electrical generation, but it cannot realistically replace household energy systems. A refrigerator, television, computer, or electric vehicle needs far more power than a simple soil battery can supply. Second, the metals aren't permanent. The zinc electrode slowly breaks down as the chemical reaction continues. The battery consumes the metal itself to create electricity. Third, the environment matters. Dry soil performs poorly since the electrolyte needs moisture to allow ions to move. Different soil types produce different results. Rich, damp soil with minerals usually outperforms dry sand. Temperature, electrode size, distance between metals, even the chemical composition of the ground all change performance. There's one more challenge: efficiency. Modern batteries store and release energy with incredible precision. Earth batteries are crude by comparison, not optimized machines, but simple demonstrations of a natural process. Maybe that's exactly why they remain fascinating. They reveal something we often forget. Technology doesn't always have to be complicated to be intelligent. Sometimes the most important discoveries aren't the ones that create the most power. They're the ones that change how we think about what is possible. An Earth battery will never replace the electrical grid, but it proves a powerful idea. Energy isn't always locked inside expensive machines. Sometimes the materials needed to create a tiny spark of electricity are already waiting around us. For more than a century, the Earth battery has existed in the strange space between invention and forgotten experiment. It was never powerful enough to dominate the world. It never replaced the giant machines that power modern civilization. Maybe that's exactly why so many people overlooked it. We often measure technology by one question: how much can it do? How many watts? How much speed? How much capacity? How much profit? The Earth battery tells a different story. It asks a simpler question: what can we create with what we already have? A handful of soil, 2 pieces of metal, a few simple connections, and suddenly, something invisible becomes visible: the movement of electrons, the hidden chemistry happening all around us. A reminder that electricity isn't some magical force trapped inside expensive factories. It's a natural phenomenon that humans learn to understand and control. Here's the interesting part about forgotten technologies. They're rarely forgotten because they were useless. Sometimes they disappear because the world moves in another direction. This invention belonged to a time when inventors were exploring every possible way to create electricity, before massive power plants, before global energy networks, before technology became something most people could only access through complex machines. It represented a different relationship with invention, one based on curiosity, experimentation, and the belief that solutions could come from unexpected places. Today, as the world searches for cleaner energy, smarter systems, and more accessible technology, old ideas are being viewed differently, not because the past was better, but because sometimes the past contains lessons we were too busy to notice. This isn't the future of electricity. It won't power cities. It won't replace modern batteries. But it teaches something that might be even more valuable. The next great innovation doesn't always have to start with something new. Sometimes it begins by looking again at something we already had. Maybe the mistake was assuming old technology was primitive. Maybe some inventions weren't outdated. Maybe they were simply waiting for better materials, better understanding, and a smarter generation to unlock their true potential. Because the future of technology isn't always about creating something completely different. Sometimes it's about rediscovering forgotten ideas and asking better questions. So here's the question: would you choose the newest technology, built with billions of dollars and decades of research? Or would you be curious about the forgotten invention that was quietly producing electricity from the Earth more than 100 years ago? Sometimes the most surprising discoveries aren't hidden somewhere far away. Sometimes they are already beneath your feet.